Hey, good morning everyone. My name's David Van Kesteren. I work in the system planning team and I'm joined today by Ian Fletcher from our smart grid implementation team. We're here today to talk to you about active network management on the Northern Power Grid network and what you can do to get connected particularly in the East Riding area of Yorkshire. So thanks for joining us today. The format of today is we've got a 15 to 20 minute presentation. I'm just trying to get the slide. Oh yeah, there we go. 15 to 20 minute presentation to go through. While we're in that presentation, for all the viewers, you'll be in listen only mode. There'll be a couple of polls, of which we're going to do one in a second, that you can participate in. And at the bottom, well, it's at the bottom of my screen, I think it's at the bottom of yours as well, there's an opportunity to ask questions. You can ask us questions any time as we go through using the question bar. We'll deal with the questions generally at the end, but if we can see them coming in, then we'll maybe tweak the material if we can to answer the question as we go through. You can also send any feedback you've got to our email address ice@northernpowergrid.com, and we will try and answer any questions offline there. But we will be running an answer session at the end, and we'll continue to take questions after the presentation. So, just to give us a feel for who we've got on the end of the line, we've got a quick poll for you. We're going to ask you whether I'm just trying to move us on, but I'm struggling. Oh, here we go. Right, I'm going to ask you whether you've got any experience of deployment of active network management schemes on our network. We have one or two out there, and obviously we've been working with some customers on particularly the Driffield scheme. So what I'd like to do is just get a feel for in the audience whether we're talking to people who have got a lot of experience or none at all, and that will help us to understand how to pitch the presentation today to you. Okay, I can see I don't know the answers yet, but I can see the answers are coming in. There's a couple more still coming, so we'll just wait a second or two, and then I'll be able to see the results and share them with you, so you know who's in the audience as well. Okay, I think we've stopped, so I'm going to end the poll there. Oh, one more, yeah. Okay, I'm going to end the poll now, and we can have a look at the results. If I can work out how to publish them, I might just have to tell you actually. Okay, so just so you know where we are, of 18 respondents, 3 people have had previous experience of ANM with Northern Power Grid, and the other 15 haven't. So that's very useful. Thank you for sharing that with us. Okay, so in terms of the agenda, we're going to talk about current network issues that we have in the Driffield area and the benefits that ANM can bring in that respect. And then we're going to move on to talk about a little bit about how active network management actually works on the network, a little bit about the principles for queuing and the cost structure, so that you have an idea of what this costs and what the customer has to pay. And then specifically, again, back to Driffield, the delivery program in terms of getting this scheme live, up and running. And then right at the end, we'll share with you some other opportunities you've got to engage with us on active network management and other topics that are coming up. So with that, I will hand over to Ian to take us through the detail. Thanks, Ian.
Okay, thank you, David. My name is Ian Fletcher and I work in the Smart Grid Implementation Unit at Northern Power Grid. Just to kick off with this first slide, this sort of summarises the current issues with regards to the mix of demand and generation on the Driffield network. The main issue here is that we're unable to connect any additional generation without customers incurring significant reinforcement costs. So basically, the network's pretty full of generation, and we can't connect anymore without sort of exceeding plant capability, if you like. So right at the top of this slide, we can see that we've got about 146 megawatts of contracted generation that's either already connected or accepted. The export capacity for generation in this bit of the network is 105 megawatts. That's the next point in the table down, with a minimum summer demand there of 17 megawatts. And if you add the two together, it gives us an overall generation capacity at minimum demand of about 122 megawatts. So we've got less conventional capacity than the installed capacity of the generation on the network. However, during the winter months, because the network demand, i.e. the consumption of electricity in this bit of the network, is higher, the theoretical generation capacity then increases to 219 megawatts on the network. So there's a big difference between those two figures in the summer and in the winter. So we can't connect any more generation to this network, as it could lead to the network being overloaded beyond its safe working limits. It's also worth pointing out that the demands, particularly the minimum demand on the network, can change from year to year. It's not nailed on that the same minimum demand that we had last year will occur the next year, and thereby it'll either increase or decrease the export capability of the network. Effectively, the ratings of the plant in the network, they'll stay the same year in, year out, but the demand's dynamic, and it's that influences the amount of headroom that we've got. So just moving on to the next slide, we have basically a graphical representation of the table that we've just looked at. If you refer to the legend over on the right hand side and the coloured lines on the graph, I'll explain which each one represents. So the coloured lines, the total generation installed capacity is 146 megawatts, and that's represented by the brown line at the top here. We've just left that static. So that's effectively full generation export all day. This is one day, a day of summer minimum demand. The summer network capacity is down at 105 megawatts here, which is represented by the yellow line. The blue line represents the summer demand. You can see that fluctuating throughout the day. So that's the demand on the day of minimum demand during the year. And combining this, i.e. adding the values to the summer network capacity, so the yellow and blue lines together, this gives us the green line up here, which is the total generation limit throughout the day. As you can see on this day, the total generation capacity line in brown up here exceeds the total generation limit line down here, and subtracting the generation capacity from the generation limit line gives us a profile for the potential overload, which is down in red at the bottom here. Again, you can see how that fluctuates throughout the day, and that's dependent on what demand the actual consumption of electricity in the network, what that's doing throughout the day. But it's worth pointing out that this is the absolute worst case during summer, as it assumes that all the connected generation is running effectively flat out for 24 hours during that day, i.e. that's probably, but it's highly unlikely. At the moment, during the winter, with an intact network, there would be no overload on this network. So we've got some summer issues effectively on the Driffield network. So what do the conventional reinforcement solutions look like, and how much would they cost to get additional generation connected? So traditional reinforcement would require the replacement of the 132 to 66 kV grid transformers supplying the Driffield network with higher capacity units. These would cost in the region of around £12 million and would release about 30 megawatts of generation export capability. To get generation connected in the Driffield geographical area would require dedicated long cable routes out of the area to alternative connection points, i.e. outside the Driffield network. Typically, these would cost in the region of around £6 million, making it too expensive for most, if not all, of the new customers wanting to connect in this geographic area. There aren't any cheaper traditional solutions available. So this is where the active network management scheme comes in. So what does ANM actually do? It's effectively a monitoring and control scheme that interfaces with both the distribution network, our network, and generators in this instance to constrain generator export at critical times to avoid overloading the Northern Power Grid network. The ANM scheme is effectively a substitute for the traditional expensive reinforcement that would otherwise be necessary. This scheme comes in at around 1.1 million plus about 100 to 150k per customer site. So you can see that it's considerably cheaper than the alternative, more traditional connection methods that we have at our disposal that would involve reinforcement or connection outside of the group. What it does is it takes advantage of higher demands on the network and allows more generation to run, and that frees up headroom that was previously untapped, and in this case, initially at least, we only expect active constraints during the summer months when demands are at the lowest. However, it doesn't come out without some drawbacks. For instance, there are no guarantees for availability, as we don't control what the existing demand does. Small scale generation, for example, domestic solar, may erode the headroom over time, and the later you join the scheme, the higher the level of curtailment you should expect to be subjected to. So, what constraints do we have, and what does the scheme look like? So we have reverse power flow constraints on the grid transformers supplying the 66 kV network. These are the ones that I was talking about would need replacement for a traditional scheme. In addition to that, we have circuit constraints on the Driffield ring, where ratings of overhead lines limit the amount of power that can safely flow around that overhead line network. There's about 72 kilometres of overhead line network on that Driffield ring that's on screen at the moment, that's coloured in red. So in order to keep these constraints in check by keeping power flows within plant capabilities, we'll need some additional network monitoring at key locations, which has just popped up on screen now. We'll also need a central controller that will be located at our Yorkshire Control Centre that will use the monitoring data in real time in its analysis. So this is effectively the brains of the ANM scheme, if you like, and it uses this network data in its real-time calculations to control what the generators can export at any one time during the day and throughout the year. There will also be some local controllers at the generator sites, and these will monitor the generator export and their behaviour and pass on the instructions that they receive from the central coordinating controller back at our control centre. So the brain, if you like, at Gelderd Road is telling the local controllers what the generators can and can't do, and the local controllers pass that information to the generator. But we already have some backbone telecommunications network between the control centre and Driffield, Beverley and Burton Pidsey, that's highlighted with the red dashed line. And we can use this to tie some of this scheme together. But we'll also need some last mile communications, so these are new comms links between some of the customer sites to get us back onto that backbone, that existing telecoms network. The telecoms network is therefore pretty key in tying this whole system together. Moving on to some of the requirements for ANM participation at Driffield. Basically, all new customers greater than 190 kilowatts, it's around 200 kVA at a 0.95 power factor, they'll have to either join the ANM scheme or will have to contribute towards reinforcement costs. This effectively means that all HV and EHV generation must join the ANM scheme or contribute towards the reinforcement that will be necessary to get them connected. Some of the reasons why existing connections might affect curtailment levels for existing ANM customers are changes to capacities within the bounds of the first point on the slide, changes to generation types and operating regime changes. There are other reasons why the level of curtailment might change in future, such as the take-up of low carbon technologies by domestic customers. For example, I mentioned more solar domestic PV could worsen curtailment for customers that are in the ANM scheme. But also conversely, if we see a large uptake of electric vehicle charging in and around the Driffield network, i.e. that would increase the demand on the network, the consumption of electricity, that could effectively improve the curtailment that customers in the ANM scheme will be subjected to. Worth pointing out though, if you do decide to connect and contribute towards reinforcement, you won't have to participate in the ANM scheme itself. So moving on to ANM applications and the queue position. If you do apply to get connected to the Driffield network, we'll basically automatically consider you for an ANM connection, but we would discuss this with you first. So we have some commercial engineers that know this network quite well, and when they see that they're getting a request for a connection of generation, particularly to this bit of the network, they'll automatically sort of look into an ANM solution and an offer, but we will provide you with either a conventional offer or an ANM offer, but we won't provide both at the same time. However, what we can do is give you an indication of the likely costs of a conventional connection, i.e. the one with reinforcement and outside the ANM scheme, and an indication of an ANM connection, how much that will cost, to help you decide which type of offer you'd like. Your queue position in the ANM scheme is currently determined by the date of a complete and competent application, and your queue position in and amongst all of the other ANM customers, that will influence the likely level of curtailment. The order in which generators will be curtailed for network constraints is based for this scheme on the last in, first out principle, which means that the last person in the queue will be the first person to be curtailed for any relevant constraint. And conversely, the customer at queue position number 1, the first person to apply with a competent application, they will suffer the least curtailment of the ANM customers. How does the cost of an ANM scheme break down? Basically, in Northern Power Grid there are two main costs. We've got shared costs and sole user costs. Shared costs are ANM scheme costs that are shared between customers to get them connected, and they're shared on a per megawatt installed ANM capacity basis. For example, if we had one 10 megawatt generation customer and one 5 megawatt generation customer, the 10 megawatt customer would pay 2/3 of the total shared cost, and the 5 megawatt customer would pay 1/3 of the total shared cost. As future customers join, rebates to existing customers can be made via reapportionment rules for shared costs. So currently this is effective from 10 years from installation of ANM equipment. Sole user costs, these are the second types of costs, are costs associated with equipment only used by the one customer. For example, the local controller that would be situated at the customer's site, or the last mile communications infrastructure between the customer site and the backbone, plus some measurement points that might solely be required for that customer's connection. Some of these elements could become shared in future if they're required by other customers that come to join the ANM scheme in the future. Currently, all of the operating and support costs are recovered via our general use of system charges, so there are no annual fees for being in the ANM scheme at the moment. So this is a snapshot now of where we've been on the ANM journey and where we're planning to be in future. So we have done quite a considerable amount of work in the background over the past few years, internally developing our policies, the concepts and specifications for ANM that we're beginning to apply now. Back in April 2016, we opened the Driffield network up to ANM connections, and we had contracts in place in about June 2017. We went to tender for ANM providers and selected our preferred provider last year. The front-end engineering design study has recently been produced, and we're just looking into that now. And we're looking to start construction in April of this year and commission by this year end. We'll also be looking to identify other network areas for ANM rollout later on this year. And with that, on that slide, I'll pass you back to David to finish off.
Okay, thanks, Ian. So just to explain what else is going on before we move into the question and answer session, we are going to run a more detailed active network management workshop on the 6th of March in York. That will be a half-day event in the morning, and then we have another couple of events also on that day, one relating to connecting electric vehicles and some sharing of information about what's going on with assessment and design fees, which are currently aiming to come into force from the 1st of April. That's an ongoing position, depending on progress with the government in terms of bringing in the necessary legislation to bring that in place. And then our next Connections Customer Forum is on the 24th of April in New York as well. And of course, we have every month, we have our Customer Connections surgeries, which you can sign up for if you want to have a face-to-face meeting with one of our commercial team or the associated design engineers to actually talk about some specific individual scheme or group of schemes if you're a developer across many sites. All those sites are available through our website, as you can see there. Okay, so I'm going to start this next poll a little bit premature because we haven't done the questions and answers, but I'm going to leave it open while we do the questions and answers. So don't feel that you've got to rush in to respond to the poll. We will be leaving it open, but we just really want to know at the end of this process whether this has been helpful for you in terms of getting more information about active network management and it being useful to you. So what I'm going to do is publish that poll now, and we're just going to leave that running in the background and move on to the questions and answers. So we've had a few questions come in, which I think some are probably for you, Ian, and there's one or two in there for me as well. So we'll work that through as we go. The first question, we had Mike submitted a question to us before we started, which was, how will this scheme affect my ability to connect medium and large size solar PV, sort of 100 kilowatts to 1 megawatt in the Driffield area.
Yeah, okay. So I think we answered this a little bit earlier on. One of the previous slides, if I can jump back to that, I'll just see if I can do that. Although the text is a little bit small for me to see. So back on slide number 10, connection at LV are excluded but limited to 190 kilowatts. So if you can come in at 190 kilowatts less, then you can get connected without joining the ANM scheme. You'll just get connected. But if you're above that limit, effectively, you've got to either join the ANM scheme or pay for reinforcement. Of course, there could be some reinforcement costs associated with less than 190 kilowatt connections.
Yep, okay. Okay, so Kieran asked us, are you intending to update the heat maps to show the opportunity for active network management? I think that is one for me.
Yes.
So on the heat maps at the moment, the Driffield network has a little flag on it that says it's an ANM enabled area. So we do have a flag, and as we look to roll out in the future ANM elsewhere, we will update that flag. But it's not very obvious, so I think I'll take away a point there that we should look at ways of trying to make that more obvious to customers when they're looking at the heat maps. So a bit of a techie question for you, Ian, from John on how are we using edge and cloud-based computing or big data analytics and machine learning for our ANM?
Well, I guess it's a relatively simple answer in that we're not. So a quick explanation of how this scheme is going to work is basically the central coordinated controller that I mentioned that we would have back at our control centre. That is effectively taking all the monitoring data in from the network, all the data it knows about what the generators are exporting, and running basic load flow studies effectively, iterative load flow studies every few seconds to determine where the pinch points are on the network. And what it's doing is it's comparing power flows against the ratings that it's got built into its algorithms, and where it sees encroachment on those ratings, it issues signals to the generators to throttle back. It effectively provides them with a target set point. The local controller passes this on to the generator and watches for a response. So if it gets a response within a certain time and sees the generator export coming down so that our plant is operated within safe working limits, all very well and good, but if the generator doesn't do anything, it doesn't do what it's supposed to do, then the local controller will issue a 0 target set point for ANM, and it'll monitor its response then. And if it still doesn't get a response from the generator, then effectively it's got control of circuit breakers on site and could switch ultimately the generator off to ensure that our network assets aren't exposed to power flows in excess of their safe working limits effectively. So no, we're not using it at the moment, but possibly in future we'll see how things develop.
Okay, thanks for that. A couple of national grid related questions that I'll take. So one of them from Andre, which asks who restricts the active network management? Is it Northern Power Grid? Is it National Grid? And we've also got a question from Kieran about is participation in the ANM scheme dependent on the statement of works process used by National Grid? So to take the first question about is it National Grid or is it us, that depends where the constraint is on the network. In this particular network, the constraint is totally within our network, so we have no interaction with National Grid for the ANM scheme that we're putting in at Driffield. However, we do have another bespoke active network management scheme in the northeast where it is monitoring the power flows on National Grid's transformers. We control the scheme, but they have a backup emergency intertripping scheme or an operational intertripping scheme in case the active network management doesn't operate in the right way and they were to see an overload on the transformers. So that question is really dependent on where the constraint is. With regard to the other question is, are you dependent on statement of works process? So whenever we connect generation to the network, once we've got an accumulation of generation, we are obliged to talk to National Grid to check that there's no impact on the transmission system. And Driffield is no exception in that regard. However, because we are limiting how much power leaves this network, we wouldn't expect it to lead to any thermal problems on National Grid's assets. But generation contributes to fault level, and reactive power coming out of generators has an impact on voltage levels on the transmission system. So there is an interaction there, and we always have to go through the statement of works process. We have been through that process recently for the Crakey-Beck GSP that Driffield's connected to, and no issues were found at that point in time. But as more generation connects, we would have to go through that process again. Okay, moving up the list now. Kieran asked a question when we were talking about the reinforcement solutions rather than ANM. Kieran was asking, are these reinforcement costs recovered through use of system charges or connection charges? So are they socialised or are they charged to the customer trying to connect? Well, we use our normal charging rules here. So if we install assets that are purely dedicated for you, then you have to pay for those in the connection charge. But if we are reinforcing something that is going to be shared by other parties, then you only pay an apportionment. And the reinforcement type solution for this network would involve generally shared assets, and therefore the costs would be shared between the customer and part socialised across our wider customer base. So the amount that you would pay would depend on the size of your generation, and therefore how much of the additional capacity you would be utilising. But they are shared costs, generally speaking. The slightly cheaper solutions where you have a direct connection but still rather expensive at 6 million, they're generally not shared user solutions, and therefore for one of those types of solutions the customer could be looking at paying for the whole connection. Okay, Ian, John's asking us, have we considered getting Tesla Energy or another storage type provider involved so that renewable energy within the group isn't wasted when we hit a curtailment point?
So we've not considered doing anything like that proactively, but I think that the information that we've got on our heat maps website, obviously there's an indication that there's an ANM scheme that's going to be active there. So if customers are interested in pursuing a connection in that area for storage, obviously there could be some interaction and some benefit between customers there. We're limited to the capabilities of the ANM scheme itself, but I'm sure that the scheme could adopt something like that. So no, we haven't been proactive in that regard, but customers are more than welcome to come to us and ask for a connection for storage in that area. Okay.
The only thing I would add to that is storage providers in our conversations that we have had have tended to not want to connect in areas that have got restrictions because of the potential that restriction might impact on them if they want to sell a service, say to National Grid, that is for demand or generation outside of the Driffield group. So our experience to date is that customers with storage solutions actually don't want to be in ANM areas, but we would happily, as Ian says, consider one if someone came forward with a proposal. So John's asked us quite an interesting question about alternative last mile solutions. I think we'll come back to you to that one offline, John, in terms of possible alternative ways to do it that you might like to propose. So Kieran's asked us, assuming that generation continues to come on, including solar PV, do we know what level of generation capacity we would need to actually trigger system reinforcement?
So I think at the moment we'd be looking to the market to decide effectively when that bit of the network can't sustain any further ANM connections because the level of curtailment is too high. So in effect, over time, as we get more generation connected, it will effectively close the door to other customers naturally because there won't be any revenue. But we do see it as an enduring solution for the time being on Driffield until such time that maybe other influencing factors come along that require us to replace assets for other additional reasons maybe.
Okay, thanks for that. Now, Ricky was asking us questions about independent network operators connecting into this network and where do they stand with it. So our position with IDNOs is we treat them in the same way that we treat other customers, is at the point of supply, or in this case at the point of connection between the independent network operator and ourselves, we have agreed limits on import and export, and so if an independent network operator wanted to connect in this area and then connect a generator to their network, we would be contracting with the independent network operator and asking them to control the generation, and they would need to pass that on to their customer. So although we haven't tested this, I think that we would be looking for the IDNO to be the interface with us as the contracting party with us, and they would then have to consider how they control their end customer.
Yeah.
But that, I don't think that's been, well, it certainly hasn't been commercially tested in our area.
No.
I don't know whether it has been elsewhere, but it's one that I'm going to go away and find out. So Bridget's asking us about how the costs get split up. If someone joins the scheme and pays in full, and then another generator joins later on and pays for their part of the scheme, does the first customer get a rebate as those costs become shared wider?
Yeah, so I think we probably covered this on slide 12 with the apportionment rules. So earlier connected customers, in this part in the slide here, earlier connected customers may be eligible for rebates up to 10 years. So the apportionment rules apply for 10 years from installation of the scheme. So yes, the earlier customer will get a rebate for shared elements of the ANM scheme.
Okay, thanks for that. David's asked us where else will we be considering deploying ANM, and that's a good question. It's certainly one of the topics we'll be covering at York. But our first priority is to get this scheme in place and fully operational and prove to ourselves and to our customers that it works effectively. But we have got a plan for later this year, as this scheme rolls out for delivery, to be looking at other areas that could be good for rollout on ANM. We're already thinking about it. We've got a few areas in mind. It's a case of picking the one that provides the most benefit to our customers. Okay. I don't know who this question came from, but someone else asked about storage facilities, and would we be looking for storage facilities within the New Yorkshire region to help with higher demand? So a little slightly off topic, but still related to controlling ANM controlling, because an ANM scheme could be used in a demand area as well as in a generation area if demand was the limiting factor and customers were prepared to turn their demand down. At the moment, we haven't identified any specific parts of our network that would require that type of connection. But if we get to that point where some sort of demand-side response could be beneficial, then a storage solution could potentially benefit. So Ian, Nathan's asked us, how does active network management cope with a fault within the network, especially transient faults, maybe overhead lines, short-time faults that then release the networks intact again afterwards?
So in this instance on Driffield, particularly with the overhead line network that we've got running from Driffield, the ring network, the scheme is set to monitor post-fault power flows, if you like. So the pre-fault power flows are being managed in advance of a post-fault scenario. We're looking to hold those power flows at slightly above ratings, but not to exceed a rating at any one point in time. What we're going to have is some overload protection as a backup. So obviously there's a limited thermal inertia capability in overhead lines that we might be able to exploit slightly, but the actual target set points will be set to keep generators down below the post-fault power flows that could occur, and that also goes for the transformers that we've got at Driffield. So say if we have two 90 MVA rated capacity transformers at Driffield, but simply the power flows will be limited to 90 MVA. So we've got 180 MVAs worth of capacity, but we'll be limiting to around 90 MVA in theory, and that's pre-fault. And that's effectively what we do for demand. It's just treating the generation the same way as we would treat a demand customer to maintain security of supply to all the other customers that are connected to the Driffield network.
Okay, thanks for that, Ian. So Bridget's asking us, how far have we got with generators joining the scheme so far? So what level uptake has been completed to date?
Yeah, so we've got 4 generators connecting to the ANM scheme at the moment. We've got 1 HV generator and another 3 EHV generators that are joining the ANM scheme, and they vary in size between around 3.5 megawatts up to about, not sure, of around 10 megawatts each. So there's a wide range in capacities in there, and there's a mix of different generator types in there too.
Okay, thanks for that. So John's asking another techie question for you here. How will ANM interface with future innovations such as peer-to-peer blockchain energy trading?
Well, I guess I don't have a crystal ball, so I'm not too sure, but I know that there are capabilities that are being developed and people are looking into merging trading type arrangements with ANM schemes. So, but I mean, I guess all that kind of facilitation is very much in its infancy. Who knows what could happen in the future? But there's a possibility there for the two things to be merged in the future.
So in this sort of general commercial area, Kieran's asked us a question about the potential for auctions. Ofgem is thinking about auctions, so where all users compete to offer the lowest charge to be constrained off. And have we got any thoughts on this? This is obviously something National Grid do to some extent, in the sense that they have contracts where they do pay customers to be constrained off. Currently, the charging rules that we apply in Northern Power Grid don't involve paying customers to be constrained off. So although the market is clearly, there could be many changes to the market currently, that isn't something that we would do. But we have thought and talked about the idea that last in, first off is a relatively simple way of determining which generators should run, and developments in the market in the future and discussions around efficiency of the network could potentially lead to alternative trading arrangements with different queuing orders. But we would obviously, our first priority would be to honour the contracts we have with our existing customers, and therefore those sorts of arrangements might only come into place with newer customers in the future. What was the Oh, did I delete the wrong question then, Ian? Kieran had another question, and I apologise, Kieran. I've just hidden the wrong question. I've just asked you that one. You've just asked us that one. I'll try and find it again in a sec. While Harlexton, right, okay. I think we've sort of answered this one, but how do we see interaction and embedded and nested networks, so independent type networks? And Ian, we've answered that, but will we be providing ANM technical scheme details? Are our technical scheme details available at the moment?
They're not publicly available at the moment. I guess we've given a brief description of how the scheme works today, but those customers, if we're talking about ID&O customers, the customers that you spoke about earlier, David, then we'd have to provide some technical information with those customers, obviously, to get the scheme up and running and to make it work. All the different interfaces that are available, the languages that different bits of kit talks to each other, and how in a little bit more detail how the scheme works, and it all ties together as well.
Okay, and we've found Kieran's question, and he's popped it back to us again. Thanks for that. So, could an existing firm customer, so someone's already existing on the network and not constrained by ANM, and a new customer coming along on ANM, could they agree to trade their constraints? So the guy who doesn't have a constraint and has all this generation, could he agree to be constrained off so that a new customer who would be constrained can run?
Yeah, so I guess our stance on that will be that the customer can do what they like between each other, so long as the ANM schemes keeps it still functions as it should, and our network stays operating within its safe working limits. At the moment, we wouldn't be particularly involved in those interactions between customers, but if the customers had something that worked for them, then I don't see why they couldn't trade between themselves. We would just have to make it work, wouldn't we, with the ANM scheme itself, because that's in control of who gets curtailed and when. There would have to be some new rules that would have to be built into the scheme to facilitate that. Yeah.
So currently we haven't got that solution.
No, we don't.
But the solution could be developed, and a commercial framework would need to be put in place so that when the unconstrained generator decides not to run to allow the other guy on, he doesn't in some way, that capacity gets stolen by other third parties. Okay, I think we've got one more question, and that is, when considering the success of the active network management system, is there a positive impact on the cost of supply in respect of keeping costs of energy down? Well, the simple answer to that is yes, because the socialised costs of the reinforcement work is spread across all customers and therefore goes on to everyone's electricity supply bill. And while ever we can avoid carrying out that very expensive reinforcement, both the individual customers are getting a win, as long as the level of curtailment is acceptable. They're getting a win because they get a cheaper connection to start with, and our wider customer base is getting a win because they are not having to fund through our socialised costs those reinforcement costs that would have impacted on their use of system charges over time. Okay, so I think that we have certainly answered all the questions that we've seen come through. So thank you for the questions, because they've been very good for us, and hopefully we've answered everything you've got. If you've got any more questions, then you can still send them through to the ICE email address, ice@northernpowergrid.com. And John will be in touch with you, and someone else has sent us a question that they wanted a private answer to. We'll be in touch with you both about some of the other questions that you asked. So thank you very much, and we're going to close the webinar there.
Thank you. Thanks, folks.